Arctic terns have stubby legs, so they're clumsy on land. But in the sky, that's a different story.
It's a very elegant bird in the air. This is really a bird that's made for life in the sky.
And, says Karsten Eggevang, a researcher at the Greenland Institute of Natural Resources, Arctic terns put that flying ability to good use.
It conducts this extremely long migration.
A migration from the Arctic to the Antarctic and back every year. The birds fly across an incredible amount of our planet, and Eggevang wanted to know more about that journey, how they get from the very north to the very south, and where they stop along the way. So in July of 2007, Eggevang headed up to Sand Island off the coast of Greenland, right here. That's where he could find 1,000 breeding pairs of Arctic terns. His plan was to attach little geolocator bracelets to the legs of the birds to log their flight paths. But that was easier said than done.
The island we worked on is a very flat island in the middle of a big fjord, so there was absolutely no protection towards storms. So we had some really, really bad weather where our tents blew into the sea.
Wait, your tents blew into the sea? Didn't you need those tents to sleep?
Yeah, they'll get just devastated by the storms.
And if the cold and wet weren't enough, and the noise, they were also under attack.
The Arctic terns are very good at defending their colony, so they would attack us all the time from behind where you didn't notice them and pick us in the head with their really pointy beaks.
And yet, despite the frosty elements and getting hammered in the back of the head over and over again by the very birds he was trying to study, Eggevang was able to set up a handful of traps.
Extremely simple but rather effective trap that we would place over the nest. And once the bird comes back to incubate the eggs, the trap will catch the bird and we're able to handle the bird.
Eggevang managed to trap 50 Arctic terns and attach the bracelets to them. And within days, the birds took off in small flocks of 10 to 20 and began their migratory odyssey. To retrieve the data, Eggevang had to get those geolocators back, so he waited a whole year for the birds to return. And when they did,
we had to find the exact same individual that we marked the year before.
How did you find the birds again? You would look with binoculars in the sky?
We would look up in the air at several hundred birds at the same time and look for that one bird that would have a small lock on the leg. So that was really time-consuming.
Eggevang would track the bird back to its nest and set up that same trap to retrieve his geolocator.
Well, we are really far away into the Greenland wilderness, so we don't have all that much to celebrate with, apart from a bottle of whiskey. So we had a whiskey when we caught a bird.
All told, he tagged 10 birds and drank 10 shots of whiskey. In a moment, we'll track 2 of the birds that he tagged. And if you look in the upper left of your screen, you can match their migrations with a moving timeline. He expected to find the birds would be in a hurry to get where they were going, but after leaving the breeding grounds, the birds spent a month hanging out in the middle of the North Atlantic.
This was completely unknown that the birds would do that.
Most of what's driving their migratory path is food, so they hang around spots where there are lots of small fish to eat, like this part of the Atlantic. They start flying south again in September.
And then something really surprising happening around equator.
There's a migratory divide, a split.
About half the bird would follow the coast of Africa, whereas the other half would cross the Atlantic and then follow the coast of South America. But even though the birds would be scattered all over the Atlantic Ocean, all of them came back to spend the winter in the Weddell Sea down at Antarctica, where they will find an iceberg and rest and just fish and eat throughout the winter.
From November to April. And then within a week, all the birds take off to begin their northward return flight.
Instead of following the same routes as they did when they migrated south, they would pick a totally different S-shaped pattern, flying towards Africa, crossing the equator around the 1st of May, and then reaching almost as far as the Caribbean before they would start flying towards Greenland.
The birds were able to take advantage of a strong tailwind by taking this particular path, so they covered a lot of ground, over 300 miles per day.
It's like the birds were in a hurry to get back to the breeding grounds, and they more or less just went as fast as they could.
Here you can see the tracks from the birds that Eggevang tagged. He can say something now about hotspots in the ocean, places that are especially rich in food not just for Arctic terns, but for other seabirds and marine mammals too. That can be helpful in deciding which parts of the ocean require extra conservation attention. And Eggevang has calculated that all the flying an Arctic tern does during its life,
it's equal to if the Arctic terns were to fly to the moon and back 3 times. That's really amazing if you look at it that way.
What's amazing to me is that the birds they're spending time in polar regions and temperate regions and equatorial regions and different temperatures. They really have to be adapted to the whole globe.
That's true.
So do you have kind of a new respect for these birds after seeing the results?
Yeah, absolutely. I mean, they are really, really tough small birds.
And because of where Arctic terns spend their time, says Eggevang, in a year they not only see more of our planet, but also more daylight than any other creature on Earth.